Hey everyone, in this video we're going to continue along on our car testing template. In our last step we just did the Understanding Formulas tab. Now we're going to use some of those same learnings to do the Newton's Law tab. So we're going to click on Newton's Law. We're going to select into the E8 portion, and it says calculate the meters per second with a division problem. So the division problem that we're going to need right here is we're going to need an equals to start us out, because we always start with an equals to do math. Now, with that being said, we're going to take 15, because that's how many, meters that this is going to be running, and we're going to divide it by, all right, the cell above. So that'd be E7. And E7, once again, is telling us how fast our car is going to run in 15 meters. And we hit enter. Now that tells us that our car is traveling then at around 14.72 meters per second. And I have a few too many spaces there, so I'm just going to back that off a little bit. All right, I think 14.72 is just fine. All right. At the same time, once again, to get all these for everybody at once, we can just select this little corner piece and click and drag that to the right. And when we release it, we'll see how fast all of our cars can go in seconds. And you can see that the heavier car is the one that's going slower. The lighter cars are traveling faster. Now, meters per second isn't all that familiar with us here because, we usually talk about miles per hour. So that's the next thing we're going to do is we're going to use a convert function to change it from meters per second to miles per hour. So here's how we do that. We select into E9, the cell, and we're going to hit equals, and then we're going to type in convert, C-O-N-V-E-R-T. And then we're going to do an open parenthesis, which is a shift 9. And we're going to type in the cell that we're converting, and that's the one right above, and that's E8. All right. We're going to hit comma, and then we're going to write in what it started as. What is the first unit? So we're going to hit quotation mark, and then we're going to do meters, which is M, /S, and that's meters per second, and then with a quotation mark again. All right. So that's where it's saying what is the unit that's starting in. And we're going to hit comma, and the next thing we're going to do is we're going to put it in the unit we want to transfer it to. So once again, quotation mark, and then we're going to do miles per hour, just MPH, end quotation mark, and then end parenthesis. All right. Now that's one that's usually kind of hard to, look at and locate. At the same time, once again, it starts with convert, open parenthesis, selecting the cell we're converting, and then we have comma, in quotations, meters per second, comma, in quotations, miles per hour, end parenthesis. Hit enter. So what this is telling me is that my car is traveling at around 33 miles per hour, 32.9. All right. Once again, I'm going to back it off this one because I have too many decimal places there. All right. And then I'm going to click and drag that once again to the right. And it'll tell me how fast my cars are going in miles per hour on all these. All right. At the same time, the next thing we're going to do is we're going to take our last number and we're going to multiply it by 27.5. So we have to hit equals. All right. And then we're going to have, E9 is our last cell, E9. And we're going to hit the shift 8, that's asterisk, which means multiply. And we're going to do it times 27.5. Now, this 27.5 is just like the scale speed. So usually these Indy cars are about 27.5 times larger than our car is. And this is going to give us a really big miles per hour number. I think I did it right. At the same time, it's saying that my car, if it was a normal size car, would be traveling at 905 miles per hour, which I don't believe is possible. At the same time, click and drag to the right to see what the scale speed is for all the cars in miles per hour. Now we're done with calculating the Newton's law. Now, the next thing we're going to do is we're going to go into roll testing. In roll testing, the first question it asks is, do a division problem for the equals the off-center and then versus the down the track. So we're going equals, and then we're going to do E7, all right? And then we're going to have it divided by E6. And then we're going to hit enter. So all that's happening there is it's giving us a rate, or a ratio essentially, of that number compared to that number. And we're going to compare or grade that across just to get it for everybody's, because everybody's is a little different. All right, this is still unitless. It's just like a ratio itself, a number compared to another number. To get this into 15 meters, how far it's going to get off track over 15 meters, now we're going to multiply it times 15. So we're going to go into here, once again, always equals, and then we're going to go E8, it's our cell above that we're multiplying, and then we're going to go multiply, so once again, that's shift 8, times 15. Enter. Now that's telling me that my car is going to go 0.4 meters off center by the end of the track. So 15 meters later, it's pulling to the right or pulling to the left by 0.4 of a meter, all right? Which I believe is something like, well, that'd be, what, 429 centimeters? If I'm doing that right. Now, with that being said, clicking there and then sliding that to the right to see our rate off center for all the cars. Now, what's happening here is we're getting an additional time underneath that's adding on to our guesstimated time, where we're adding time in seconds below. And the greater the number above, the more time it's adding in seconds. So you can see that mine has very little impact, all right? Like at 0.05 or 0.5 of a second, almost 0.06. But if I had a car pulling more off to the right or left, it's going to add more time for friction, like a tenth, a tenth versus 100th. Now, with that being said, that's all of our roll testing. Now we go to aerodynamics. We've already done that, and it's adding our time there. Then we're going to go to educated guess. In the educated guess, you get to now do an equal sum to find out all of our stuff together here. We're ignoring the top piece because that was our weight in grams of our car, but we want to add up all the things underneath. So how we do this is by coming into here, selecting into E10, and hitting equals, and then SUM, because it's going to do an addition, and we're going to do an open parenthesis. It's going to start at E7, and it's going to go shift, so it's colon, to E9, all right? And then we do close parenthesis, and then hit enter. And then we can see that overall, my start time plus my time for friction plus my time for aerodynamics is giving me an educated guess time of 1.106 time in seconds. Once again, click that, hover over the corner, and drag that to the right to get all the people's cars. Now, here at the end, now we can go to graphing. And in graphing, there's one thing that we're missing, and that is our actual race time. But over here, you can see our different cars. And you can see the formula time, which is kind of just a math problem that we use kind of physics to kind of figure out if a perfect scenario, what's going to be happening here. And then we have also an educated guess time, all right, which usually we add a little bit more time in seconds. That kind of goes on that way. And then if we enter our race time in here, if we get time to get to our race times, usually those run a little faster. Sometimes it's as much as like 0.2 off. So I might have a car that races like 0.905 or something like that in seconds over 15 meters. And then if I had that enter in there, you can see my race time is also right there. All right, so my race time usually ends up being a little bit below my formula time and a little bit off of my educated guess time. Meaning my data probably isn't perfect, but it kind of still gives us a setup about what are we doing, what are we thinking about here when we, I guess, are getting to the end of making our cars. And, this is kind of the end. At the same time, if you do get your race time, enter those in, because then you can see those data points on the graph. All right, and you can see this linear piece, the heavier the car is, all right, in grams, the slower our car runs in seconds. All right. Well, I hope everybody had a good time learning some things about Google Sheets. I hope you have a great time. You had a great time making your car, and I hope you're excited about racing. Have a great day. Thanks for watching the video.